Hi, Deacon John Wilson here, Education Enrichment Director for West Angeles Church. Here's some information I'm surprised I haven't done in all these years, but I will more now. Many of you know for almost 20 years I was a systems engineer and a product engineer for two large aerospace companies, Hughes Aircraft Company, now Raytheon, and Northrop Grumman, and got a lot of experience there. And it was a big factor in me knowing I wanted to go back to the community and help youth to do things in related to engineering. We need more black and brown, frankly, engineers, female engineers, and I thought I could have an impact. That was one reason for it. But here's a great video, young people, that will help you to young people who are watching this, who will help you to sort out the engineering field and know what it is that you like to do. Stay tuned right here. Next, you'll see a great video on it. I'll comment after.
There are many in-demand jobs in technology, and especially lucrative career option is engineering. Engineering careers are similar to the medical field in the sense that you don't just simply choose to be an engineer, just like you don't simply choose to be a doctor. You have to pick a specific engineering discipline as there are many subcategories within this career field. Some of the most popular engineering fields include software engineering, electrical engineering, mechanical engineering, and industrial engineering. But how do you choose what type of engineering job is best for you? In this video, we'll go over different types of engineering careers, what they do, what kind of education you'll need, and a lot of other things. So what are the different types of engineering? While there are many varieties, most share some of the similarities with each other. A software engineer spends most of their time creating computer programs or applications. If you're watching this video on YouTube, or really anything other than a traditional analog television, you're viewing an application that was created by a software engineer. The daily activities of a computer engineer include various other duties, such as fixing coding bugs, creating integrations with other websites, and building new features to help users accomplish their goals on the internet. According to Glassdoor, in the United States, software engineers earn an average over $100,000 per year. Next, an electrical engineer's job will typically involve designing an electrical system or electrical equipment. Electrical engineers work with computers, cell phones, and basically any device or item that transmits energy. The daily responsibilities of an electrical engineer could include testing an electrical system, solving any problems that come up, designing a circuit board, or checking a system or a piece of equipment for safety, and much more. According to Glassdoor, electrical engineers earn an average salary of $97,000 per year. A mechanical engineer must be able to design 3D product blueprints, find efficient ways of manufacturing products, run simulations to test those products. But like every other type of engineering, problem-solving skills are imperative for mechanical engineers. On average, mechanical engineers earn an average salary of $85,000 per year. In many ways, civil engineering is what most people think of when they think about what engineers do. Civil engineers are involved in the planning of public works, like roads, bridges, dams, and other large projects. Indeed, civil engineers are the folks that make our environment livable and usable in the modern world. According to Glassdoor, civil engineers earn an average salary of $84,000 a year. The work of chemical engineers is primarily devoted to developing manufacturing processes for chemical components. That is, chemical engineering is concerned with manufacturing and using chemicals in fields like pharmaceuticals, energy, and other realms involving specialized understanding of chemical elements and chemical processes. Chemical engineers earn an average salary of $102,000 per year in the United States. As you can see, although these different types of engineering vary widely in their responsibilities, they do share some DNA. All of them have to do with designing something and testing it to make sure it works well. In some ways, these jobs can exist without each other. Electrical, mechanical, and civil engineers all use programs developed by software engineers. Electrical engineers design circuit boards that allows software engineers' computers to work. Mechanical engineers develop the various components of the computer, and so on. All engineering jobs have a common ground in some ways and different in others, but their responsibilities aren't the only differences. As you can see, the average salaries of electrical, mechanical, and industrial engineers are all fairly close. Software engineers are particularly well compensated, with the average salary being nearly $20,000 more than average industrial engineer. Software engineers also have some of the highest salary potential, with top earners bringing home around $124,000 per year or more. In addition, senior engineers, on the other hand, have a much greater earning potential. A senior software engineer, for example, can make around $150,000 a year, with 112 being a national average. Again, if money is one of your primary motivators, software engineering might be your best option. One way in which most of these engineering jobs are similar are their educational requirements. Most of these jobs require at least an undergraduate engineering degree from a university. Of course, if you wish to pursue education past the bachelor's degree, your initial salary may be higher. One notable exception to the rule is software engineering. It's one of the few types of engineering careers you can begin without a degree. While the traditional path to a career as a software engineer has been to get a computer science degree, today many people get jobs in this field attending a coding bootcamp instead. Keep in mind, all of these jobs require you to stay up to date with current trends and changes in the industry, so the learning process never really stops. Even though these jobs existed decades ago, if someone who started software engineering in the 90s tried to apply the same skills today without any new knowledge, they would be very lost. The same goes for electrical, mechanical, and industrial engineering. With a rapid pace the technology develops and changes, these jobs change as well. Of course, each of these jobs comes with their own sets of pros and cons. Let's take a look at some of the reasons why you would or perhaps wouldn't want to choose a specific type of engineering career. Software engineering has many pros and a few cons that are worth mentioning. Chief among the best aspects of this career are the high salaries. Software engineers get paid very well, especially as you get more experience in your career. Another pro of software engineering is physically, it isn't very labor intensive. Much of your work will be done in a comfortable office space on a computer. Although for some, this may be seen as a con if you like to use your hands and move around your work environment. Another encouraging aspect of software engineering is the fact that it's a high in demand job, meaning you won't have to worry too much about there not being enough jobs in your city. Plus, some employers allow you to work remotely, so you don't even have to leave your home. Depending on your position, software engineering work hours aren't too demanding either, and you'll work a typical 40-hour work week. Electrical engineering also has many benefits, and again, a few downsides. As you might imagine, the pay for electrical engineers is definitely attractive. Also, electrical engineering is a fairly flexible job. There are various industries that you could apply your skills in. And unlike software engineering, you may get to use your hands more and get out of the office every once in a while. That's not to say that you won't spend time at a computer though. Electrical engineers use programs to design and map out systems and circuit boards. Also, a con of electrical engineering is the inherent dangers involved with working with electricity. Obviously, there are plenty of safety measures in place, but an electric shock is still a risk of the job. You could apply many of the pros of being a software engineer to mechanical engineering careers as well. Mechanical engineers often work in a comfortable office much of the day, though you may get to leave the office sometimes depending on your specific job. Also, mechanical engineering is one of the most varied engineering careers around, meaning these professionals have a great number of industries to choose from. However, mechanical engineering isn't without its potential downsides. These engineers earn slightly less than others. Plus, many top-earning mechanical engineers take home well above a six-figure salary. Another potential con is the stress associated with this job, but this is often the case with just about any other engineering career. Chemical engineering has much to recommend it. It's one of the better-paying engineering jobs with an average pay in the low six figures and as many as 10% of the practitioners clearing $150,000 per year. While engineering fields tend to have broad applicability, it's hard not to marvel at the sheer variety of places chemical engineers can end up, which can be a major plus. However, chemical engineering comes with its fair share of dangers, but specific work-related hazards vary between jobs. If you can handle the complex subject matter and potential hazardous work, chemical engineering could be an excellent career choice. Finally, let's take a look at the different paths you can take to pursue a career in each of these types of engineering. To become an electrical engineer, you'll need to have a bachelor's degree at the very least. Though you could seek a job that offers to pay for your postgraduate schooling in order to save money. After 4 years of job experience, it's a good idea to get an engineering license. Mechanical engineers also need a bachelor's degree, and a master's degree is often encouraged. A mechanical engineer must get a license in the state that they want to work in as well. Like most engineering professions, the journey usually starts with earning a bachelor's degree in chemical engineering. As the ranks of the college goers continues to swell, it's becoming more and more important for you to distinguish yourself. Arguably, the most straightforward way to do this is by completing one or more chemical engineering internships while you're in your undergraduate or graduate programs. Now let's talk about how to become a software engineer. Surprisingly, despite having the highest average salary, becoming a software engineer doesn't have quite a big of a barrier to entry as other careers in this field. That's not to say that becoming a software engineer is easy, but it's the only engineering career where you don't need a degree. If your self-taught skills are strong enough, you can even get a job as a software engineer without a degree. And with useful resources such as coding boot camps, you can expedite your path to becoming a software engineer even quicker. Now, hope this gave you a quick introduction to the different types of engineering, and please comment below what types of engineering you find most interesting, and let's break in.
Hi, Deacon Wilson back. I hope that video helped you to learn about the different engineering professions. Let's summarize what we saw there. Here's a good summary of what you saw there. And again, I'll make this sheet available to you. In fact, you're in my class now. Right in front of you is the sheet. This is a summary of all the various engineerings: computer engineers, medical engineers, manufacturing engineers, civil engineers, chemical, mechanical, environmental, industrial, aerospace, electrical. There's a couple he didn't mention. Computer engineers, they create hardware and software found in everything from automobiles, video games. That's more of an area of systems engineering, which I was. I was a systems engineering in aerospace. And, this is what I did. I help the different branches of engineering on our program work together in a major system. And that's what computer engineers do. In fact, my degree was in electrical engineering with a computer science option from George Washington, way back in ancient times, 1980 students. So, electrical engineers, it says down here, just underneath computer engineers over here to the right, left, you can see their kind of design, electronic computer systems, etc. So I was a systems engineer, and I helped people to talk together. There were even some physics majors that I worked with and math majors as well that were on this major engineering programs that I worked. And I moved on to work in the program office as an engineer, where we helped to market and sell our designs to the federal government. All right, I just wanted to let you know what I did, then how all these other great engineering careers come together. Next time I'm with you, we'll talk about coding and how that all fits together. But here's a question I'd like for you to consider in your groups. I'd like you to look at these various engineerings and kind of vote among your group. Which one is your first, most interested one, your second? No fair saying none. I want you all to think about these. And I'll give you about 5 minutes to work on it and to talk about, which ones are your favorites among these. Remember, pick two, and we'll discuss what you picked. Maybe some of you will tell me why you picked it as well. God bless you. Thank you for your attention. Bye-bye now.